Alright, so I'm going to walk you through building a full adder. First you need to know what a full adder is, which is a digital circuit that performs addition. So it adds three 1-bit binary numbers, which are 2 operands and a carry bit. Now, to build this full adder, we will need 2 XOR gates, 2 AND gates, and an OR gate. So let's go ahead and get the AND gates, and we're going to put them as close to each other as possible for efficiency on the board. So 2 XOR gates. One can go here. Let's get a little closer. One there, and another there. Alright, then we do need an OR gate, which I can place right there. Alright, so now we need 2 inputs. So these 2 inputs are going into the XOR gate. Just place them right here. We could label one A. Just label it A. You can label the second one as B. Alright, perfect. Now, with regards to efficiency, we need to get rid of all of these pins. So we only need 2 pins per gate. Let's just go ahead and cut these down to 2 pins. Okay, 2 pins. Alright, 2 input pins per gate. Now, for the first 2 inputs, A and B, we're going to have these connecting to the input pin for the first XOR gate. And just go ahead and make the connections. Now, being a full adder, this does take 3 inputs. So it takes a carry in input. Let's label this carry in C underscore IN. Alright, so it takes a carry in input. Now we're going to connect this XOR gate to the XOR gate in front. Might need to move this a little. And that's okay. At times you're going to have to reorganize your gates to account for the efficiency. Alright, so we're definitely going to need a connection from here to the AND gate. We're definitely going to be connecting this XOR gate to this AND gate like so. Now this is where the carry in comes in. It's going to be connected here. Alright, now we want to get this AND gate connected to the inputs here for A and B. So A definitely comes down, all the way down, and is connected here. B comes all the way down also and is connected to this AND gate. Alright, now what we need to do is provide an output. This output will be the sum. So this is the sum for the addition of 3 values. Let's just label this S for sum. Yeah, and this OR gate, the output for this OR gate will be the carry. So this will be the carry value. Just fix that. So this will be the carry value. I'll just put an output pin there also. Alright, so let's label it carry out. So C underscore out. Alright. Now we need to connect the AND gate to the OR gate. Connection right there. Another connection right there. Alright, now this should be our fully functioning full adder. Now the point of this is to actually show you that we can have multiple adders, creating a chain of adders to carry out various operations. So this simple operation, as you know, with adding binary numbers, if we're adding 1, or let me just change to, alright, so if we're adding 1 plus 0 plus 0, we know the sum is 1 and the output is 0. 1 plus 1 plus 0, the sum is 0 and the output is 1. Now 1 plus 1 plus 1, the sum is 1 and the output is 1. Now what's really cool about this, so as I was explaining before, let's remove this carry in input there. Let's just remove that. Let's remove that. And let's get our half adder right here. Let's copy this entire, okay. Copy this entire thing. Yeah. We can place it, let's place it right here. Or let's move it down to here. Yes. And now where we have our carry right here, we can remove this and connect this carry right here. Now we can do this with multiple full adders even. So for this half adder, as you know, 1 plus 1, 0 carries the 1. Now this 1 being carried, it's added to the input of A, which is 1, B, which is 1. So 1 plus 1 plus 1, 1, carry 1. Now we can go on and on and on with these, but yeah, that's the basic idea. Now if you have any questions, do leave them below in the comments, and I'll be available to answer them. Also, if you're not sure what the gates do or what they stand for, go ahead and watch my previous video on logic gates building circuits.